Okay, so as advertised, I wanted to go through this problem and show you how to get the correlation coefficient. So what I would do is I would start to set this up in Excel. And so I'm just going to open a blank Excel page here. And so we have 3 oranges, 2 apples, 2 bananas, and we're selecting 6 pieces. Okay, so we have 7 and we're selecting 6. All right, so in this case, X is the number of oranges, Y is the number of apples. So let's just make a little chart here. So X is the number of apples. I'm sorry, X is the number of oranges. Okay, and we know that can go from 0 to 3. Okay. And Y is the number of apples. And that can go from 0 to 2. Okay? And this will be where our probability mass function is. We'll just make a little table like here. Okay, and there we are. And so we want to now decide if there are any values that are disallowed. And we see that there are some. For example, if we pick 0 oranges and 0 apples, we'd have to pick 6 bananas, and we can't do that, right? So this is not allowed. Okay. We can't have 0 and 1. Okay. We can't have 0 and 2. And we also can't have 0 and 3. Okay. We can't have 1 and 0. So basically, if the number of fruits added together is less than 4, we can't have that possibility, right? So we can't have any of these. So this is 4, so this is possible, right? This is not possible, and these are. So all I really have to do is just compute the PMF for these values, right? So this is going to be equal to combination, okay? And it's going to be 3, I'm sorry, the number that we have here is 3 choose 3 times and we have 2 apples, and we're going to choose 1 from that, times, and now we've chosen 4, so we have to choose both bananas. So the combination 2 choose 2 is going to be 1, so I won't bother writing that down. And of course, this is going to be divided by a combination of 7 choose 6, which is just 7. Okay, so again, I won't bother to write that. Here, it's going to be 3 choose 2, which is 3, times 2 choose 2, which is 1. We've chosen 4 pieces of fruit, so we have to choose both bananas. So it's just 2 choose 2, which is 1 divided by 7. And finally, we come over here. Okay, 3 choose 3 is 1, 2 choose 2 is going to be 1, 2 choose 1 is going to be 2 divided by 7. And I didn't put an equal sign there. Okay. What the heck? I have to format this apparently. Okay, and there we are. And I can check myself by taking the sum of all the probabilities, right? So if I just want to check myself really quick, I can add up all these probabilities and they should sum to 1. And I'll just add them straight up. It's easier to do that. Okay, good. So the probabilities look good. Okay, so now I'm going to go ahead, I'm going to take the marginals of, let's see, x. Okay, so I'm going to hold x constant and sum over y. And it's just going to be basically this. I can just drag it down and copy it. And I'm going to sum these two. So there we go. And the marginal of y, it's, whoops. And I'm just going to sum these two. Okay. And there are so few values that, you know, I could easily do this by hand. That's okay. Okay. So now, in order to get the correlation coefficient, okay, rho is equal to the covariance, which is the expected value of x times y minus the expected value of x times the expected value of y, divided by standard deviation of x times the standard deviation of y. Okay. So, and of course, some of these are actually quite easy to get. Okay. So I can get the expected value of x quite easily. This is just going to be equal to the different values of x times the PMF. So it'll be 2 times the PMF of 2 plus 3 times this. Oops. So that's the expected value of x. The expected value of y. Same sort of calculation, right? I'm going to take the values of y, multiply it by the PMFs of that value, and then just add them. So this will be equal to the PMF at 1 times 1 plus the PMF at 2 times 2. Okay? And finally, I need the expected value of x and y. So here, there's a couple of ways we can do this. Probably the easiest thing to do, if you had, for example, a much more busier PMF. So here, you notice I only have 3 values. Okay, so one way of doing this, if I had a table where I had more things filled in, is I could put the values of x and y here. So in fact, let me just do that. I'm going to put zeros here just to kind of show you what I mean. Okay. So this is my PMF. Okay. And I want the expected value of x and y. So what I can do is blow this up a little bit. I think I'm just going to compute it just straight out. It really isn't that hard. What it is, I'm just going to go ahead and just take the PMF times x times y, and just, whoops, and just do this for each value, right? Actually, it's this one right here, plus PMF times the value of x times the value of y, plus this times 3 times 2. Okay? And that gives me the expected value of xy. All right. Now I can go ahead, now I can do the covariance. So this is going to be equal to the expected value of xy minus the expected value of x times the expected value of y. And I'm going to get the correlation the same way. I'm going to take the expected value of x squared, which is actually easy, right? So if I look at x here, right, it takes on values of 2 and 3. So this is just equal to 4 times this plus 9 times this. The expected value of y squared is going to be equal to, well, this is 1 and 2, right? So 1 squared is 1, so it's just this plus 4 times this. Okay, and now I can go ahead and calculate standard deviation of x and y. This is equal to the expected value of x squared minus the expected value of x quantity squared, and standard deviation of y is going to be equal to the expected value of y squared minus the square of the expected value of y. And now I'm ready to calculate the correlation coefficient. It's just going to be equal to the covariance divided by the product of the standard deviations. Hold on, 3. Oh, I calculate the variance. I need the square root of these. I calculate the variance. How did I know that was wrong? Well, I had a correlation coefficient that had a magnitude greater than 1. So as soon as you see that, right, there we go. And that's going to be our rho. Okay. So the rate limiting step really is calculating the expected value of x, y. And so that's a little tricky. I mean, you can make a matrix where you have the matrix of the x, y values multiplied, or you can just go ahead and do what I did. Just, just do each of the multiplications by clicking on it, which is still faster than doing it by hand.